Hey everyone, welcome to this video about component architecture in React. And as you can probably see, I got quite a bit of an upgrade. I actually got a new camera and changed the background. It's still work in progress, but please let me know down in the comments what you think about it. So in this video, I'd like to focus on the answer to the question when something should be a separate component, which is for a lot of developers, you know, both beginner and more experienced, always like a pretty difficult question to answer. So the first thing I'd like to talk about are abstractions. So there is like not one definition of what an abstraction is in software development, but I found this one online. I modified it a little bit, and I think for the purpose of this video, I think it's a great example of what I mean with an abstraction. So it says an abstraction is the purposeful suppression of some details and components in order to bring out other details more clearly. And the reason I'm emphasizing purposeful is that making an abstraction doesn't always mean it's useful, right? And I think when you go to the React docs, and I know that currently they're working on like a major rewrite of the docs, so this example might not be in like the next version of the docs, but as you can see right here, it's called Thinking in React. And what they do is they will take this piece of UI. So you got like a search bar right here, and you have like a select button where you can show only products in stock. And then right here, you got like a sort of table where you have the name of the goods, the price, and well, when it's red, I assume it's not in stock. And what they do right here is they break the UI in like a component hierarchy. So they break it up in 5 components. So you got the filterable product table, which is the whole thing, pretty much all the components together, which contains the entirety of the whole UI component right here. Then they got the search bar, which is blue, which is essentially the component that receives all the user input. Then they have the product table, which displays and filters the data collection based on the user input. And then they have like the product category row, like the turquoise kind of color, and then they have the product row, which is red. So they make like 5 components, and of course for the product rows they still use the same component, but it's essentially in the like the React DOM tree, it shows up as separate components. And honestly, this could be a very bad design choice in your React app, but it really depends on, you know, how your app looks like. How is it designed, right? So are these pieces of UI, are they reused in certain parts of the application or not? And it also depends on how complex are each of those components. Maybe right here it looks like a very simple piece of UI, but maybe these components hold a lot of logic. And then in those cases, and we will get to that later in this video, it might be a good decision to like chop that piece of UI up in different components. But let's say we have an application where this piece of UI is only used once, and the state and logic that is in it is fairly simple, then I see absolutely no reason to make 5 components, right? That would be over abstracting your React app, so to speak. And if you have done like the TypeScript part of this course, you will find that, you know, then you probably have to pass down a lot of props down. You have to write all your like TypeScript types for the props. It would just take a lot more time. It will make your code harder to understand for other people because they see like, you know, if imagine you have an application like this one right here. This is like a Figma design. And let's imagine you have an app that looks somewhat like this. Oops. Let's zoom in a little bit. So this is like a, I don't know, like a travel or photo app, I think. And well, as you can see right here, we have a lot of small little, you know, things right here. And we could make like all like separate components of all these things. But you can imagine that you will probably end up for a relatively simple app like this, which has like, I don't know, like 15 to 20 screens or something like that. You will end up maybe with like dozens or even like over 100 of components, which is completely nuts, in my opinion, completely nuts. That will really make it very hard for other developers to understand what's actually going on. And that leads us to the KISS principle, which I really like, and it stands for keep it simple, stupid. And the idea is that most systems, let's say code bases, work best if they are kept simple rather than made complicated. And I think that is a very valid thing in software development, right? Often you're working on projects that will have to be maintained for years, where other developers will join the project, where other developers will leave, and like maybe newer developers even have to train like more experienced devs. Like the easier you keep your code base, the easier it is for everyone, doesn't matter whether you're like a junior, medium, or senior developer, to pick it up and to actually get started and get productive with the code base. So my advice right here is to prevent making unnecessary abstractions. Only create an abstraction when it makes sense. And NC Dodds has a great article about those potential problems. He lists, I think, about a dozen of them. And I will link down to that article in the description. But I can tell you that most of the time you will encounter three problems that are most common. The first of all is when code reusability becomes problematic. So let's imagine we go back to that thinking in React example. So let's imagine that the product role right here is a component that is a little bit styled, for example, is a little bit more complex in terms of how it looks. And well, we're, for example, using that in multiple parts of our application. And now someone comes onto us and say, hey, I want to have like the price on the left side instead of the price on the right side. So that would then mean that you might have to go through like, I don't know, like all the places in your application where that piece of UI lives, and you have to change it like manually for like every separate page or, you know, thing it lives in pretty much. Now, if you would have made a component out of it, you can simply change only that one component and it will be done for like the entire application. So that's really nice. And if you find yourself, you're like on your way to duplicating a lot of code. I mean, like duplicating once or maybe twice in an application is not always like a very bad thing. You might have heard before about the drive principle, which is like part of Solid, which are well, essentially design principles for software development. And the idea is right here to, let's say you have like two functions. This is like an approve customer function and an approve employee. And what you can see right here is that we have essentially we're duplicating this piece of code right here, but we only change, well, in this case, like employee with customer. Like in those cases, like the drive principle says, well, it's probably better to make like another function that probably takes then in the customer or the employee or pretty much the entity as a argument. And then you only have to like write it once, and you can, if you, for example, have like also approve, I don't know, employee 2 and 3, you can just use that same function and you don't have to repeat yourself in the code base, which is generally speaking a good principle, but it shouldn't be your main goal in a code base to keep everything as dry as possible. Because I've seen code bases where some people, like some developers, went so harsh on like the dry principle, where for me as a new developer, it was like almost impossible to understand what was going on. It was just like an overly abstracted piece of mess. And they, of course, because they created it, they knew where everything lived and how things worked. But for me as a new developer, it was pretty much impossible to get started. So don't like fixate too much on that dry principle. Some code duplication might not be a bad choice, right? It all comes down, I think, to simplicity. How can you make your code base as simple as possible? And of course, keeping in mind maintainability and good coding practices. Also, a good reason to make an abstraction is when state management becomes difficult. Like in React, nothing would hold you from writing like your entire application in one component, but you can imagine that if you count on average like the state hooks, the amount of your state hooks you're using in a React app, which can be hundreds and hundreds of them, like if they would all live in one component, you will have like a serious problem, right? It will become very hard to like navigate throughout the code base, and it will just be like one big mess. So when state management becomes difficult, also an abstraction, so taking a piece of UI and put it in its own separate container, component, you could say, might be a good decision. And also when the performance suffers. let's go back to the example I talked about before. So you have like all your use state hooks of your entire application in one component. You know that whenever a use state hook changes, React will re-render all the children. But let's say we only have one component. That would mean that our entire application is re-rendering. Well, you can imagine that will lead to serious performance issues. So, of course, that's like a bit of a strange example because nobody, at least I hope nobody, is writing their entire app, React app, in one component, unless it's like a very small one. But then you probably shouldn't use React anyways. But, you know, like when code reusability, state management, or performance becomes a problem because of, you know, like, well, you could say too much code living in a certain component, then it might be good to split up a part of the UI and make it its own separate component. In the end, it's about finding a good balance between making and not making abstractions, right? Because often not making abstractions at all will lead to a code base that is hard to maintain, that is based on bad design principles that will just kill not very well. But making too much abstractions will make your code base very hard to understand for other developers. And thus you could say it also has a bad influence on the maintainability of the code base because it will take longer to refactor, to implement new features, to fix bugs, and so on. And of course, now I'm talking about finding that balance, but you have to understand that that balance is subjective, right? Not every developer will agree on, you know, the same balance, you could say. I think it is just up to, you know, trial and error, right? Throughout your career, you will just find out about certain decisions you made that afterwards might not have been the best decisions. And we go on to your next project and you will do it different. And I think it just takes time. It just takes practice to find that balance, what's good for you. But maybe you will eventually, I don't know, switch jobs or something like that. You come into like a new team and they might have like a complete different idea about finding that balance, right? Where that balance should be. Maybe you come into a team where they like very much fixate on the dry principle. If they do, show them this video, okay? But, you know, make abstractions when it becomes a problem. That's the main takeaway from this video. So thanks for watching, and I'll see you in the next one.